One issue you may run into with any of your programs is the exhaustion of a particular resource. What comes to mind is obviously memory. If you declare too many variables, you will eventually run out of memory. But there are some easier ones to run afoul of, and one of those happens to be file handles. If you open too many files at the same time, most operating systems have a limit to the number of file handles you can have open simultaneously, and the operating system will start throwing exceptions, and you will essentially crash your program. So the best way to deal with a situation like that is to always clean up after yourself. When you're done using an object, you clean it up. Now in Python, because of the garbage collector that's used, we typically don't pay attention to that feature very much, because when a function is done executing, any variables allocated in that function will eventually be cleaned up by the garbage collector because they fall out of scope. Well, the problem with the file handles is you have to explicitly open them, and if you don't explicitly close them at some point, the garbage collector will not clean them up because the file handle is still open. So what we have to do is we have to be extra cautious when we work with limited resources. And one of the ways we can do that is by the use of a context manager. And a context manager allows us to allocate an object using a with block, and when the with block is done executing, it'll automatically call a specific method, the exit method, so you can clean up after yourself. So let's take a look at the problem first of all. In this code, I have a list called file descriptors, and I'm going to loop for 100,000 times, and in that loop, I am simply going to open a single file for read access that 100,000 times, and I'm going to append it to this list. So what I'm really doing here is just opening a file over and over and over again to the point where the operating system is going to fail. And for fun, we can see exactly how many it takes to do that. So we can say if x, let's do it by hundreds, is equal to 0, print x. So that way we can see how far we go before it dies. We're just going to, every 100, print that value so we can see where it's at. We can put it in a try block as well and capture it, but this might be the easiest way to do it. So I'm going to hit run. Okay, it's going to continue running for some time. And somewhere around 8100, the operating system decided we had too many files open, and it crashed on us. So clearly, the way this code is written is not robust. Most of the time, I can't think of why we'd have to have 100,000 files open at any one time, but this isn't a demonstration of what you should be doing in code. It's just a demonstration of what happens if you keep opening files and forget to close them. Let's say you are processing files that's coming in on an FTP directory, and you keep opening them but forget to close them. So maybe a couple weeks into your running of the program, all of a sudden you get this random crash and you can't figure out why. And it's because you keep opening a file, but you're forgetting to close it. And clearly at around, on my computer using Windows 10, at around 8100 to 8200, somewhere in there, it's going to die. Okay, might be around 8192 because that's an even power of 2. I believe it's 2 to the 13th. We can check that real quick. Let's say print 2 to the 13th. Yeah, so there's a good indicator here that it is an even power of 2, and that might be what it is. In any case, we don't want to do this. We want to be able to clean up after ourselves. We want to control our object lifetimes. That's what a context manager is going to help us do. So let's go ahead and comment out this code so we don't accidentally run it again. And then I'm going to blow away the kernel because I really don't know what state it's in right now. So the kernel will restart. I don't need this line anymore. And let's talk about the proper way to work with files. So let's say we wanted to open a file. Well, before using a context manager, let's do it this way. We'll say f equals open, and then we'll say the file name, which is test.txt for read purposes. Then we could say s plus equals f.read. We're going to read something out of the file. Then we want to explicitly close the file, and then we can print s. You can see it read the file, and it only contains this is a test. So we opened it, then we closed it. There is an easier way. By using the context manager, we can still use the s. I'll keep that. And I'll still use this open command, but I'm going to use it within a with statement. And then I'll say as f. So instead of saying f equals open, I'm going to say with open as f. So the open variable, the opened variable, the file, will be stored in f. And now as long as I stay within the with block, I have access to that f variable. I can say s plus equals f.read. Now the file will close automatically. Print s. I'll do that outside the block. And we get the same result, but the difference is I don't have to call close. As soon as the block for with ends, it'll call a method internally for whatever this file object is. So let's actually print what file is. Print type file. Oh, not file. F. It's an IO wrapper, a text IO wrapper. So once this class is done being used, this object, F is an object of type text IO wrapper. Once it is done being used, it will call a method internally called exit, or _exit, and that's the trigger to the text IO wrapper that it's time to clean up the file. So when we use the with command, we're basically entering a context, and the context is this object here. So F is the thing being managed. When we say context manager, F is the thing being managed. And when F falls out of scope, in other words, when the with block ends, then F can be cleaned up. Let's create our own file manager class. And this is going to emulate this text wrapper. It'll be a little different because we're actually going to be using the text IO wrapper internally. But it's going to demonstrate when things happen. So let's say we create our init, and it's going to be self, file name, and mode. So those are the values we pass into the constructor. And we are going to have an internal variable, and I'm going to call it file handle, and I'll set it equal to none. Then we are going to store the file name passed in to a class variable, an instance class variable, and we're going to do the same thing with the mode. So we come into this init function, we create a new object called file handle, which we're just going to set to none for the time being. Then we store the file name and mode variables passed in, those parameters, into instance variables. I'm also going to print that we're in init. Okay? And let's just say like this, myFileManager.init. All right. Then I want to have an open method. Now this is one that I'm creating for my class that has nothing to do with the context manager. This has to do with opening a file. And I will print that that's where we are. and then I'm going to open the file. First, I want to make sure it's not already open. So if self.filehandle is not equal to none, then I'm going to say self.close. Now, we don't have a close method yet, so just be patient. We'll get to that one. But we know we're going to have a close method since we have an open. Otherwise, what we're going to do is, not otherwise, we're just going to open it. So we'll say self.filehandle is equal to open self.filename self.mode. And that's all we have to do for open. It's just going to open the file handle. Now, we could be nice and actually return the file handle itself as well. It's a nice enhancement to the open method, so we have a reference to the file handle to use externally. But we also need a close method, which is an instance method. And in this, we're also going to check to see if the file handle is valid. If it's not equal to none, instead of saying self.close, we're going to say self.filehandle.close. Now, what's the difference? Well, when I'm in the open method, I'm going to take advantage of the close method I created here. So if a file is already open, I'll just call close. And then I could say print, I'll just copy this here. So when we're in the close method, we don't want to simply say self.close because that'll be a non-ending recursive loop. It'll just keep calling this method, etc., until we run out of stack space. So we are telling it explicitly now, close the file handle. And there's really nothing wrong with just us always saying self.close. We don't actually have to check for it being open in the open method, because the first thing it does in close is also check to see if it needs to be closed. So we could do away with this check if we so wanted to. I like it because it's showing explicitly what we're thinking about doing here. So we just have a regular file manager class now that we can create using similar code to what we did up here. As a matter of fact, I'm going to use that and just modify it for our purposes. So instead of saying f equals open, I'm going to say, maybe we'll call it fm equals file manager, and we'll pass it the file name and the mode we're going to use. And then I'm going to open the file. And if I wanted the handle, I could store it here. And then I could say read off of that file handle that was passed from the open method. And then when I'm done, I'll close it. Now, as long as I got everything right, you'll see init, open, close, and then this is a test. So you can see it here. This is the init. That makes sense. We open it, we read, then we close it, then we print the contents. Now, if we wanted to, we could perform open several times, and you'll see we end up getting a bunch of close calls intermixed. The first time we open it, it just opens it because it's already none in the file handle variable. But the second time we call open, it recognizes it's not none anymore, so it explicitly closes it. Then we open it again, which closes it, which then opens it, and then we explicitly call close here, and then we print the text. Okay, so that just verifies it's doing what we want, and we're actually behaving well when we are utilizing our object. But what happens if I do this? And then delete the file manager. You can see here, at no point does it call close, but the object's already gone. So we have an orphan file handle here, and I'm not sure exactly how long it takes to clean that up, if it in fact does clean it up. The garbage collector may catch that and may close it. I'd have to look at the source code for the text.io wrapper class to see what it actually does there. So this is what we're trying to avoid. So one of the things we can do to our class to help ourselves out is to add those special methods for our context manager. And those methods are, we have an enter, which indicates we're entering the context manager. And let's just put a pass for now. And then we need an exit. And once we've defined these methods, we no longer have to worry about closing the file explicitly once we tie these together to our open and close methods. Okay, now notice here enter and exit have different signatures. Enter just requires a handle to the class object that we're opening and working with, but exit requires a few other things, and this is for debugging purposes for the most part. Okay, so we don't have to really worry about these right now for our purposes. So what are we going to change here in enter and exit? Obviously I don't just want passes, because that means do nothing. I want to add the code here that will actually do the opening and closing. So I'm going to copy the print method here to indicate we're in enter. And then I am simply going to say self.open. One of the requirements of the enter method is it must return the object itself, because if you look at how the with works, this command is going to actually create an object and store it in this F. So that is basically what we're doing here, is we have to return that object which represents the context manager. Exit is going to be similarly simple, except we're going to say exit now in the print statement, and take a guess what this is going to say. If you said close, you're absolutely correct. So we're just going to leverage the methods we already created for opening and closing our files. Let's run this class again, and then I'll skip down to here, and then I can say with, and remember how the syntax works. We do the command for creating the object and store it in some variable. So we're going to say with, and then my file manager. We're going to pass it the parameters for the file name and read mode that we have right there. And then we're going to store it in our file manager object. Then we can print the file manager, file handle. If you remember, that's the name of the object that holds it open, .read. And now when I run it, you can see we hit the init. Then it immediately goes to enter. So it calls the initializer, then it calls the enter command, which in turn triggers the open. So if we go back up here, that's what enter is doing. The first thing it does, it calls open. We have then read the text. That's where the print command comes in. Then we leave the context here, which triggers the exit, which in turn calls close. So you can see basically all of our methods have been hit, and we have cleaned up after ourselves. That is the whole point of using a context manager, so we can control better the lifetime of our objects. Now, does every class that you create require something like this? No. The answer is no, because most of the time, if you don't have a limited resource that you're accessing, the garbage collector in Python is going to do just what you need. However, as we start moving into more complex topics like multi-threading, where contexts are important, where we don't want to hold open threads longer than they're needed because we'll run out of those even faster than the file handles possibly, then yes, we are going to want to start looking at using this, especially if we're creating classes themselves that represent individual threads. And again, that's not for this topic because that's a much more advanced topic. So it's just a good introduction to the right way to deal with objects and making sure we clean up after ourselves.